Hello friends, welcome to today's class. Class number 3 of oscillation. So what we discussed today? In the previous class, we discussed the equation of SSM and the different terms also. But today class is, I'll say, very important class of this oscillation chapter. So this class is very important class. Nearly this class only has 50% weightage of the whole chapter. Maximum questions will be asked from this class. This is the most important class. So what we are going to discuss today? We'll start today the examples of simple harmonic motion. What are the examples of simple harmonic motion? Simple pendulum. Number 2, loaded spring. Number 3, liquid in U-tube. Number 4, cylinder on the surface of water. Number 5, a body at the center of earth. Number 6, a bulb at the neck of airtight chamber. 6 I told. Another is also there. A bulb along any chord of earth. So 7. So all these 7 examples are very important. So first 6 what I told. First 6 generally they comes in the school exams. Most important 3 marks questions. First 6 means in this chapter you will get 6 3 marks questions. We'll discuss. But we'll start from the simple pendulum, which is the king out of this 6 again. Means simple pendulum is very important. Very important. Most important 3 marks question you can say, most important 5 marks derivation also you can say, always comes in exam. Have you seen pendulum? The answer will come from your side. Mixed answer will come, some will tell yes, some will tell no. But you have seen pendulum clock. Pendulum clock you have seen. So what is actually this pendulum? What is the definition of the pendulum? When this question will come in exam, what will write first? First the definition of a pendulum. Simple pendulum. What is this pendulum? You note the definition. A heavy metallic bob suspended from a rigid support by means of weightlessness, flexible, incompressible, weightlessness, flexible, inextensible string. This is the definition of a simple pendulum. Okay, I am explaining you the definition. Heavy metallic bob. I have one real pendulum. Today I will not show you the green apple pendulum. I have the metal pendulum. Heavy metallic bob. You can see. This is the metallic bulb. See here. Suspended from a rigid support. Rigid support means your fan is now suspended from a rigid support. The support is not coming down. Suppose instead of holding this, if I will support in a rubber band, suppose in a rubber band I will hang this thread. Then what happens to the rubber band? The rubber band will come down. The rubber band will bend. That is not considered as a rigid support. Rigid support means it just remain as usual. If you will hang this pendulum, you may hang your fan, but still there is no problem in the support. So heavy metallic bob suspended from a rigid support by means of weightlessness. So this is weightlessness. Though you will not find like this weightlessness, completely weightlessness, but still its weight is negligible. Weightlessness inextensible. Can you extend it? Inextensible. That's the ideal case, though there will be little extension, you will see. So, but inextensible. Flexible. See, flexible it is. Not hard, it's flexible. So, I hope you understood what is weightlessness, what is inextensible, and what is flexible. Heavy metallic bulb suspended from a rigid support by means of flexible, weightlessness, inextensible string or thread is called as simple pendulum. But what question will come in exam? Question will come in exam like this. So that simple pendulum execute SHM and hence derive the expression of its time period. In all 6 examples, questions will come like this. You have to prove that the loaded spring execute SHM, hence derive time period. Liquid in U-tube execute SHM, hence derive time period. All questions are similar. Before going into this pendulum, I'm just giving you a general format. Don't worry that 6 questions are there. So how I'll practice 6 questions? But all questions are coming under a format. If you just understand in which format all questions are, then it will be easy for you. What is the format? From the equilibrium position, remember, pendulum is now in its equilibrium position, means net force on the pendulum is 0. Pendulum is not executing any type of a motion. From the equilibrium position, you just displace the body. A little you displace. Just you displace a little from the equilibrium position. If it is spring, you displace a little. You extend it a little. Along which line it can move, you just displace a little. From the mean position or from the equilibrium position. In all examples, you do like that. Ball is at the center path. Center path is the equilibrium position. You just displace a little. Downward or upward, you just displace a little. You just displace a little to the body. And find what are the forces act on it. Draw its free body diagram. What are the forces act on the body? And which force is acting towards the mean position and responsible for this simple harmonic motion? Which force is acting towards mean position? You just find out that force, because that is important here. You just find out that force which acts towards mean position, which is bringing the body towards the mean position. Just find out that force. That is important. That is your job to find out which force is acting towards mean position. If you got the force, then your job is over. Now the question becomes easy if you will find the force. In all cases, you do like that. Then the question becomes easy. Let's see how the pendulum executes SHM, how will you prove it. But in all cases, what we'll do? Execute SHM means how will you prove it? We'll find the condition. Condition of SHM, I had told you from the first lecture. What is the condition of SHM? Acceleration proportional to negative of displacement. If the SHM is linear, remember, if linear, but if angular SHM, then acceleration is what? Alpha is proportional to negative of angular displacement. Angular acceleration proportional to negative of angular displacement. If angular SHM, you have to prove this one. If linear SHM, you have to prove this one. If you will prove this condition, if you reach at this condition, then you will write one line that the body execute SHM. Then you will find its time period. I told you, question will come like this. Prove that it executes SHM, hence find its time period. I hope you understood the format what I am going to do. Now let's enter. Now let's enter. So we'll make the pendulum. So this is the pendulum, you see. This is now the pendulum. We have to consider when you draw the pendulum, what quantities will take. We have to also specify the quantities. What quantities will be specify here? M is equal to mass of the pendulum. Mass of the pendulum means mass of a bob, because string we have already told weightlessness. Okay. So then L is the length of the pendulum. Remember, it is important. Length of the pendulum. But what is the length of the pendulum? What is the length of the pendulum? Length of the pendulum means from the support, string length, this is the string, its length. Then this pendulum, when it is hung, it has one hook. Then the pendulum. On the hook, the string is attached here. One hook is there. Length of the pendulum means length of the string, length of the hook. See here. Length of the pendulum means length of string plus length of hook plus what will take? The radius of the bob. Radius of bob. Why it's a radius? Why not it's a diameter? Because distance is measured up to center of mass. Distance is always measured from center of mass to center of mass. So it's a radius. In practical lab, also you have to calculate the time period of a pendulum. I'm telling you how we'll do. In the practical lab, how we'll find the length. Okay, see, this is the length of the string. How will you find the length of the string? By the help of a scale, normal scale, you have that. Then length of the hook, you see the hook. If clearly you can able to mark, you mark the hook here. Here is one hook in the pendulum. Okay, this hook length also you will measure by the help of normal scale. Then after hook, this bob, its diameter you will measure by the help of slide calipers. Then from the diameter you will make it half. You will use slide calipers to measure its diameter, then you make half so that you will get its radius. So this is the all total is the length of the pendulum you will consider. So now what I had told you, just you displace it a little from the equilibrium position. I displace it a little from the equilibrium position, it will execute SHM like this. Any position between mean position and extreme position, you take any position of the pendulum. So what forces act here? Mg. What forces act here? Tension. This angle is how much? Theta. Let theta is the angular displacement. Very small angle. Theta is very small angle of a displacement. Okay? Theta. You have to also mention theta. Very small angular displacement. Let suppose. Then we need the force which act towards the mean position. So you resolve weight into two components. One component at this side, one component this side. Into two components. If this is theta, then this is theta. Then this component is how much? Mg cos theta. Theta, theta, corresponding angle, theta, theta. Then this is mg cos theta and this component is mg sin theta. So which component is now acting towards the mean position, mg cos theta or mg sin theta? You mark here. This is the mean position, so mg sin theta. It's very clear. So the force which acts towards the mean position, that is your restoring force. That is responsible for SHM. That is your restoring force. So here, but here, not only restoring force, we have to find out what? Restoring torque. Why restoring torque? Because it is angular SHM. So you have to find out restoring torque. Restoring torque, now you see, Tau is coming how much? Restoring torque tau is equal to, you know, torque is equal to force into perpendicular distance. So restoring torque, how much is the force? Mg sin theta. What is the perpendicular distance? L. L is the length of the pendulum. Okay, so mg sin theta into L, and minus sin phi, minus because it is restoring. It is restoring. Okay, so that's why there is minus sign. So is equal to, implies that here in place of tau what I will write? I alpha. From where I got it? I alpha. You know F is equal to ma. So F is equal to ma in the corresponding formula. In place of F, tau. In place of mass, moment of inertia. In place of A, angular acceleration. You know this. Tau equal to I alpha. Then minus mg sin theta. So mg in place of sin theta, mg L, but L I now wrote here. In place of sin theta, I wrote theta. How? In place of sin theta, I will write theta? Yes, no problem. But when it is possible? When it is possible? When theta is very, very small. When theta is very small, in that condition you can write sin theta nearly equal to theta. This happens, theta is very small means let's take 0. So sin 0 is equal to 0. But not exact, not 0, but if it will be non-zero and very small, then sin theta is equal to theta. You have already also used this in physics. When theta becomes very small, you can write sin theta is equal to theta. If you expand theta, other terms will come and they will be neglected. Only one remains, that is theta. Anywhere, when theta is very small, you can write in physics sin theta is equal to theta. So I wrote what under a condition that theta is very small. This is the condition used here. You see, in the practical lab, when you will find the time period of the pendulum, you have to displace a pendulum by small angle. By small angle like this, see. Then you have to find its time period. You have to calculate the number of oscillations, you have to find this time period by small angle. But some students, what they do, those who don't know about this theta, that theta should be very small, what they generally do, they saw, if you just oscillate it by small angle, it is very difficult to count the number of oscillations. It is very difficult. What they do generally, they start from here, they will take it to a longer height, then they will leave it, see. They will do like this. 1, 2, 3, 4, 5. They count like this. So now it becomes a little more easy to count. If it will go to very high, when theta is very large, then it's very easy to count. Okay. But in that case, this pendulum is not executing SHM. Remember. In that case, pendulum is doing oscillation, but oscillation is not a simple harmonic when theta is large. Only pendulum executes simple harmonic when theta is small. Remember, for small angle of theta. So alpha is equal to minus mgl by I into theta. But what is I? Moment of inertia, mr square. So I will write this ml square here, theta. Mn cancel. So minus g by L into theta. This is alpha. G is constant. Length of the pendulum is constant. So how alpha depends on theta? Alpha directly proportional to minus theta. Got the condition? Now you got the condition. So what line you will write here? So the pendulum execute simple harmonic motion. So we'll write here, so the pendulum executes simple harmonic motion. One line you have to write it there, otherwise teachers will not give you mark. So the pendulum executes simple harmonic motion. But you just recall in oscillation formula, what is with y, what is there? That is what? Omega square. The same thing also happen if alpha is there. What is with theta? That must be what? Omega square. From that we will find time period. Remember, alpha directly proportional to minus theta. So the pendulum execute as a same where omega square is equal to G by L. In place of omega square, what is there? G by L. So what about omega? G by L root over. What is there with theta? That is omega square. In all examples also you will do like that. Remember, one format. So omega is 2 pi by t. So G by L root over. Then t is equal to 2 pi L by G root over. This is the expression of time period of pendulum. You must have heard this expression. You must have already used this expression. Very, very important formula. Time period of a simple pendulum t is equal to 2 pi root under L by G. So this 3 marks question is now over. Time period to prove time period 1 mark, and to show that it executes SSM, that is 2 mark including figure. Then again from this, many questions can be attached in this pendulum. Many means how many? Many questions. If we discuss the questions also, then I know it will be better for you. So now let's discuss what questions can be asked from this pendulum. So time period expression you have to remember, because that is the important part for us. With that expression we will proceed forward. So t is equal to 2 pi L by G root over. Must remember this expression. First, question number 1. You see, in the time period expression, is there any mass of the pendulum? Is there mass is there in the time period expression? See, is there mass? No. So what is the concluding line? Time period is independent of mass. Time period is independent of mass. It doesn't depend on mass of the pendulum. Sometimes question will come, pendulum mass is 2 gram, another pendulum, but length is same. Length same, but mass different. Mass is of 4 gram. Doesn't matter. Time period remains the same. Your answer will be same. Time period of both pendulum will be same. Questions may be asked from this concept, that is, time period of a pendulum is independent of mass. You must remember. Number two, what question can be asked here? What is the time period of a pendulum inside satellite? This is the most important 1 mark question. Remember, most important 1 mark question. What is the time period of a pendulum, simple pendulum, inside satellite? Inside satellite means what is the value of G? What is the effective value of G? 0? If the effective value of G is 0, then what happens to time period? In place of G you put 0. Then time period will come how much? Infinite. The same thing also happens where inside satellite, just like satellite, where the same thing happens at the center of Earth. At the center of Earth also value of G is equal to 0. Time period of pendulum infinite. Inside a freely falling lift, what is the effective value of G? That is also 0. Means time period is also infinite. So from one concept again 3 questions comes. Inside satellite, at the center of Earth, inside a freely falling lift. In these 3 cases, effective value of G is equal to 0. So time period equal to infinite. Very, very important questions will be asked in exam, 1 mark question. Then come to point number 3. Now what happens here? The pendulum is now fit in a lift. Okay, now come to lift. Yes, but before going to lift, I am telling to you this pendulum, we'll just compare this pendulum with potato. Potato is such a vegetable which is used in all curries, everywhere. Potato is such a vegetable. We generally tell in day-to-day life, are you a potato that you are mixing with everybody? You are mixing with everything. Okay, potato is such a vegetable which is used in all curries. Just like this pendulum is such an important concept, such an important part of physics which enters in all chapters. I will say this pendulum and Newton both have same character. Pendulum can enter into all chapters as well as also Newton. You must know also Newton, starting from laws of motion to also not left heat, wave. In all chapters, Newton is there. Newton's formula is there in all chapters. Just like the pendulum also entered in all chapters. You see, pendulum has also entered in error chapter. You must have done pendulum question, error question. One example of an NCERT book, very important. Okay, so pendulum now entered in which chapter? Laws of motion chapter. Just before also I entered the pendulum in gravitation chapter, because pendulum entered inside satellite. It will enter in all chapters of physics. And when it enters in all chapters of physics, now the question become complicated. Take with pendulum, you can make questions in all chapters. See, so lift is moving upward with acceleration A. Lift is moving upward with acceleration A. One pendulum will fit here inside the lift. So, in equilibrium position, downward mg, upward tension. But which one is greater? When the lift is going upward, which force is greater? Obviously T is greater. So T minus mg is equal to ma. T minus mg is equal to ma. Then T is equal to how much? M whole into g plus a. Then effective value of g dash is equal to g plus a. G plus a. Now what is the time period? 2 pi L by g dash, so g plus a root over. This is the time period formula when the pendulum is in a lift and the lift is moving upward with acceleration a. Next. So number 4. Pendulum is inside the lift. Lift is coming downward direction with acceleration a. The same figure. Pendulum is coming downward direction with acceleration a. If it is coming downward direction with acceleration a, then which one is greater, mg or t coming downward? So mg greater. So mg minus t is equal to ma. So implies that t is equal to m whole into g minus a. So now this is the effective g. Then what will the time period? T is equal to 2 pi L by g minus a root over. Pendulum is inside the lift. G minus a root over. When the lift is coming downward with acceleration a. But when the lift is falling freely, then what happens? Lift free fall means what happens to its acceleration? Acceleration is equal to g. Freely falling lift means acceleration is equal to g. If the acceleration is equal to g, then g minus g. See here, what is the time period? 2 pi L by g minus g root over. So it's 0, then infinite. I have already told you this concept just before, that inside a freely falling lift, time period is also infinite. So this is lift. Then come to point number 5. Point number 5 now come. What happens here? So suppose the pendulum is inside a box. Pendulum is inside a bus, inside a carriage, we can say bus, and bus is moving horizontally with acceleration A. What are the oscillations of the pendulum now? Effective oscillation of the pendulum we have to find out. So downward oscillation is G, this horizontal oscillation is A. If bus is going with oscillation A, the pendulum is also going with oscillation A. Then what is the effective oscillation? G dash. G and A are perpendicular to each other. According to parallel axis theorem, according to parallelogram law of vector addition. According to parallelogram law of vector addition, so what is the effective value of G? G square plus A square root over, because both are perpendicular to each other. Vector addition. Okay. So then now time period T is equal to 2 pi L by G dash root over, means 2 pi L by, in place of G dash, G square plus A square root over, again whole root over. This is the time period where the pendulum is fit in a bus and the bus is moving horizontally with oscillation A. Then come to point number 6. Each point is one important question. Now come to point number 6. One important part, seconds pendulum. This one we should discuss in point number 1, but we have brought it in point number 6 by mistake. Why? Because this is more important. Between all points, seconds pendulum, scientist, name is second, the great man. After his name, the unit of time is given, second. Seconds pendulum. What happens to this pendulum? What is the time period of this seconds pendulum? 2 seconds. The pendulum has time period 2 seconds. That's called seconds pendulum. Seconds pendulum, that is. Time period is how much? 2 seconds. So 2 seconds means that is also called as ticks second. Remember, time period 2 seconds, that's also called as ticks second. Remember this word. In ancient book, one example is there. The question is, find the length of the pendulum which ticks second. That means that is which pendulum? Seconds pendulum. But some students misunderstood that ticks second means they take the time period as 1 second. No, don't do like that. That's a common mistake in that question. Ticks second means tick, tick. It becomes 2 seconds. Tick second. Tick means it's a half oscillation. Tick, tick. Then time period is 2 seconds. When the word is like this, ticks second, then you remember time period is 2 seconds. But we will find its length. How will we find the length of seconds pendulum? 2 pi L by G root over is 2. 2 then cancel. Then we have to find out its length. Take the square in both sides. Pi square L by G is equal to 1. Then L is equal to G by pi square. Calculation you will do. That's your job. You will do the calculation. How much we get? 0.96 meter or 0.9996 like this meter you will find, which is nearly equal to 1 meter. This is more important, most important. Sometimes some students, without doing the calculation G by pi square, they directly write length of the seconds pendulum is 1 meter. You also remember this one. Length of seconds pendulum is 1 meter. Must remember. Okay. So in exam the question will be asked, what is the length of seconds pendulum? Calculate the length of seconds pendulum as a 2 marks question. In the 3 marks derivation of simple pendulum, if this 2 marks second pendulum will be attached, then the total will be how much mark? 5 mark long question. So this is the point number 6. Now, pendulum already entered in the laws of motion chapter. Now we'll enter the pendulum in fluid chapter. Also it can be entered in fluid. Yes. Now enter the pendulum in fluid chapter. So point number 7. Fluid means you take in a container, take fluid, some liquid you take, liquid density is rho L, pendulum density is rho, and pendulum is inside this. Inside it, the pendulum executes SSM inside the liquid. Find its a time period. What happens? What are the forces act here, you see? Don't worry, what are the forces act? mg, here tension. Another force acts on the pendulum in the upward direction when it is inside the liquid. Which force? That is upthrust. Upthrust act in the upward direction now. Upthrust. So, now what happens in the equilibrium position? When it is in equilibrium position. So what is the equation now you see? T plus U is equal to mg. T plus U is equal to mg in the equilibrium position. Okay. So implies that T is equal to mg minus U. U means upthrust. But what will do upthrust? Thrust formula is what? Vd rho Fg. Remember, upthrust formula is Vd rho Fg. Vd means displaced fluid, rho F means density of a fluid into G, weight of a displaced fluid. So this is the mass of a displaced fluid, volume of a fluid displaced into density of a fluid. So Vd rho Fg, this is the formula of thrust. What I will put here? V. Why V? Because the displaced fluid volume is equal to the volume of the pendulum. Is equal to volume of the pendulum. Then rho F means rho liquid. I wrote here. I will take rho L into G. Okay? Rho L into G. Then mg in place of a volume of the pendulum. So we know density of the pendulum is equal to its mass by its volume. Rho is the density of the pendulum, mass by volume. So in place of a volume, what can I write? Mass by density. Then rho L G. So you take now mg common, you take m common, 1 minus rho L by rho whole into G. Whole into G. So in place of acceleration, what is there? What is there with m? So this is the acceleration here. So what is the effective acceleration? Effective acceleration is equal to 1 minus rho L by rho whole into G. This is the effective acceleration. Okay. So what to write here? Time period. So time period T. What to write here? Time period. T is equal to 2 pi L by G dash. So time period T is equal to 2 pi L by G dash root over. Then G dash value we will put it here. Then you will get the expression of time period of pendulum. You will put G dash expression. Okay. So this is the pendulum when it is inside the liquid. Means pendulum entered in fluid. Then pendulum will enter in heat and thermodynamics. You want to see? Yes, we will enter the pendulum in heat and thermodynamics. Now you see. How? How enter in heat and thermodynamics? Point number 8. Pendulum will enter into heat and thermodynamics. Temperature of the pendulum increases. If temperature increases, according to linear expansion, the length of the string increases. If length of the string increases, see, if temperature increases, suppose theta, I have taken theta as the temperature, then length of the string increases. If length of the string increases, then time period increases. Then time period increases. If length of the string increases. So you want to see You want to relate between the temperature and time period, how the question will come in exam. Question will come like this. Temperature increases by theta amount. Find the fractional change in time period or the delay in time period or the delay in time in one day or the percentage change in time period. I'm again telling you the question. If possible, you note down. If temperature of the pendulum increases by theta, find the fractional change in time period, percentage increase in time period, or the delay in time in one day. So now let's find. But one question is coming to mind. Sir, what delay you are telling? I can't able to understand. I understood, okay, time period will change because when theta increase, length increase and the time period will change. We will find the fractional change in time period. Means change in time period by original time period. But what do you mean by delay in time period? Yes, that I am going to tell you. Listen carefully. Your pendulum clock will now show delay in time. How it will show delay in time? Your pendulum clock. Okay, so pendulum clock is calibrated. When the company made the pendulum, one word you may have listened somewhere, calibrated in physics. How the calibration is done? When it executes one oscillation, then it show 2 seconds. 2 seconds. One oscillation, 2 seconds. I'm telling according to seconds pendulum. So when one oscillation, it will show 2 seconds. It is calibrated like this. Okay, both are matching with each other. So that means you see this part is very important. One is the calibration is done. One is your pendulum. One is pendulum and one is time zone. Pendulum oscillation and the time zone are just matching with each other. Pendulum one oscillation takes how much second? 2 seconds. Your time also recorded or time shown to you by the clock is also 2 seconds. But due to increase in temperature, your pendulum time period increases. It takes more time to execute one oscillation. It takes more time to do one oscillation. More time means it takes now time, suppose 2.2 seconds. To do one oscillation, the pendulum takes 2.2 second time. But your clock can't able to understand that one. Your clock is calibrated that when one oscillation will be there, then it will show 2 seconds. The clock will show 2 seconds. But actually the pendulum is taking 2.2 seconds to do one oscillation. But your clock is showing you 2 seconds because clock is calibrated like that. In one oscillation it will show 2 seconds. Your pendulum is taking more time than what the clock will do. It is already made like that. So that means the actual time is 2.2 seconds, but your clock is showing 2 seconds. Time delay is there or not? The actual time is 2.2 seconds, but your clock is showing 2 seconds. How much delay? 0.2 seconds. Delay is there in every 2 seconds. In every 2 seconds there is delay of 0.2 seconds. That's why when temperature increases, your pendulum clock will be delay in time. Remember this one. So now let's find the fractional change in time period, the delay in time period, everything we will find. Now so what is the time period? T equal to 2 by L by G root over. But due to increase in temperature, length increases. So if length increases, what is your new time period? T dash, that is L dash by G root over. Because length increases, no problem to G. If length increases, what is the formula? Just recall the formula of linear expansion. LT is equal to L naught whole into 1 plus alpha delta theta, or I am writing alpha, temperature increase delta theta, you take here, you write here also delta theta. Okay, recall the formula. New length is equal to original length whole into 1 plus alpha delta theta divided by G, its root over. Now you do t dash by t. Just divide these two equations. Equation 1, equation 2. Just divide them. You will divide, what will get? 2 pi cancel, g cancel, l cancel. You can divide it. Then it is coming 1 plus alpha delta theta divided by nothing. 1 plus alpha delta theta. It's a half power. It's a half power. Half power, how will you find? One theorem is there, the universal theorem. Which theorem? Binomial theorem. So I will multiply half here. In this way we use the binomial theorem. Just multiplying the power in the second term, we write here using binomial theorem and neglecting the higher order terms, because the second term is very small. Alpha is very small. Okay, binomial theorem is used here. So t dash by t is coming like this. So now t dash by t minus 1. Bring the 1 to this side. So in next step we will do t dash minus by t minus 1 is equal to half alpha delta theta. So now take LCM. Now take LCM here. T dash minus t by t is equal to half alpha delta theta. So t dash minus t is nothing but del t. Del t by t is equal to half alpha delta theta. So this is the fractional change in time period. This is the fractional change in time period. You got one answer now. Fractional change in time period. But what will the percentage change in time period? If I ask percentage change, then you do del t by t into 100. Then if you multiply 100 here, you will get 50 alpha delta theta. This is the percentage change in time period. You can also remember this formula to solve the MCQs. 50 alpha delta theta. You can remember this formula also. Then, what is the delay in time in one day? What is the delay in time in 1 day? Now let's see. Delay in time in 1 day. Use their formula. Del t by t is equal to half alpha delta theta. This one. This delay means delay is del t. Delay is del t. The increase in time period, that is the delay. So let's find that del t. Half alpha delta theta into t. T means in how much time? In 1 day. 1 day means 24 hours. Convert the hour into second. Convert the hour into second. Then we will get one formula here. How much time is delay in 1 day? If the question will be asked how much time is delay in one oscillation, one oscillation means 2 second time period. Okay, seconds pendulum. If you 2 seconds in one oscillation, then you put here 2 seconds, then 2 to cancel, you will get half alpha delta theta. So like this. This is one important horse. Another question also I can tell you here, but that I'll tell you as homework. You will do that one. You will try at home. Very simple. If length of the pendulum increases by 2%, what is the percentage increase in time period? You try it. I have already done this type of question. If length of the pendulum increases by 2%, what is the percentage increase in its time period? So in today's class, we discussed many questions of simple pendulum. Hope you understood it. Thank you.